Hi, as you know, Excel had NPV and IRR functions for a long time, but up to now there was no payback period function, and we had to calculate it manually using other formulas. So now we have a new payback period function in Excel, and the new payback period function is called PBP. So let's see the new function in action. Here we have a project and its cash flows from year 0 to year 5. These are the after-tax cash flows, and these are the cumulative cash flows. So looking at the cumulative cash flows, we can see from year 3 to year 4, it changes from negative to positive. So the payback period is somewhere inside year 4. To calculate the payback period, we can now use the new function. So I'll type it over here, equals PBP, and I need to give the values. These are actually the after-tax cash flow values. So I give this range like this and close the bracket and press enter. So I get 3.2 as the payback period. So it should be correct because it's 3 years plus somewhere between year 4 it becomes positive. So we can manually calculate this to check whether it's correct. So from year 3 to year 4 we have an after-tax cash flow of 125,000. So at the beginning of the year 3 the cash flow was negative 25,000, and end of the year it has become 100,000. So the payback period is here where the cumulative cash flow becomes 0. So from this break-even point over here to this point, the cash flow is 100,000. So that is the cumulative cash flow that has occurred in that year, year 4. So to manually calculate the payback period, we have to assume that the cash flows are occurring evenly throughout the year. So we can calculate the payback period like this. It will be the first year when cumulative cash flow is positive. We'll call that N, minus cumulative cash flow in the first positive year, that we will call it X, and then divided by after-tax cash flow for the first positive year. We'll call it Y, and that is 125,000. So let's try it over here. So the first year when cumulative cash flow is positive is when it's year 4. And from that we minus cumulative cash flow in the first positive year, that's 100,000, divided by the after-tax cash flow in the first positive year, that's 125,000. So we get the answer 3.2. So it's the same answer we got from the function. So now that we have the function for PBP, we don't have to manually calculate it like this. We also have a new function to calculate discounted payback period called DPBP. So I write the function over here, DPBP. And here I have to give the values and then the discount rate as well. So in that case, it will be the weighted average cost of capital over here. So first I'll give the values, this range, comma, and the rate is 11%. And I close the bracket and press enter. So then I get 3.86. So the discounted payback period is longer than the normal payback period. That is because the cash flows lose their value as the time progresses. So it's 3.8, or if you round it, it's 3.9 years. Actually, these are new functions we created for our convenience, and they are not available in Excel. So as you can see, these new functions are pretty useful, and then you don't have to do it manually every time. So let me teach you how to create these new functions for yourself. So here I'm in Excel. I'm going to get into our Excel training app from the ribbon over here. Our Excel app allows you to take our training courses inside the Excel application itself. Now I'm going to load the file I need for the demonstration. So this is the demonstration file. So we have the project, and these are the cash flows from year 0 to year 5. And these are the cumulative cash flows. So I've used the sum function to add this cumulative cash flows. I'm going to build a payback period function step by step, so it will be easy for you to follow. So first we need to change the cumulative cash flow calculation formula from this sum function into the modern dynamic array scan function. So I'm going to get the scan function to calculate the cumulative cash flows instead of the sum function. So I will type here equals scan, and the initial value I'm going to put as 0, and then the array that I want to sum is this array, and the function I want to use is sum. So I will enter that formula. So I'm getting the same cumulative sums as I got with the sum function over here using the scan function. So how the scan function works is when you give an initial value, here I'm giving 0 as the initial value, and then I'm giving an array or a range. What this scan function will do is it will keep on summing all of these values until it gets a full range of cumulative sums. So it starts at 0, then it adds 250, and that is shown over here, and then 200,000 likewise. So this function is over here in this cell, and it spills into this range. So this is the function I used. Now I need to get a sequence of years like this from 0 to 5. Here, of course, I have just calculated with the addition formula. So 0 plus 1 likewise. I have added until I got 5, but I need to get a sequence in one formula. So I can use the sequence function for that. So I will type it here equals sequence, and the number of rows I want is 1 row, and then the number of columns is how many years I have from 0 to 5. So what I'm going to do is to calculate that automatically, I'm going to use the count function. So it becomes dynamic. So I will count the cash flow range like this, D12 to I12, close the bracket. That will be the number of columns in this case. Because I'm starting from 0, I will get 6. And then the starting value is 0. And the step or the increment I want to increase is by 1. So I can close the bracket and press enter. And I got a range of numbers from 0 to 5, demarcating the years. So this is the function I use, sequence function. Then I need to find out when the cash flow, the cumulative cash flow becomes positive. Is it in year 2, year 3 like that? Of course, visual I can tell it's in year 4 that it becomes positive, but I need to do it with formulas. So I can use a formula initially like this, equals D13 greater than 0. So I get a false here. It's not greater than 0. So I can copy it like this. And here at this point, it becomes positive. So the value becomes greater than 0. So I get a true there. So this formula I'm going to use to identify when the cash flow becomes positive. So that I'll be using in the formula. So since I used the scan function over here to calculate that same range, I can use that range inside the same formula here like this, equals, I can give the range like this, D15, and I put a hash to identify the spill range, and I can do the logical test whether it's greater than 0, and I can press enter. So I got a spill range now here, giving the false and true values. Now in the final payback period, I can't have this D15 hash inside the formula. What I can have is only this after-tax cash flow range, D12 to I12, this range. So I have to replace this D15 hash with the scan function that I have used here. So what I can do is I can copy the scan function from here, Control C, come here, type equal and Control V to paste, and I again put greater than and 0. Then I get the same values as I got before, and the final formula has only this D12 to I12 range. The next step is I need to calculate the first year with the positive cumulative cash flows. To do this, I'm going to use a match function. So I will type equals match, and the lookup value what I want to look for is true, and the lookup array is this range starting from D22 and hash for the range or the spill operator. And the match type I want is a exact match, so I put 0 there and I can press enter. Now I get a answer of 5 instead of 4. That is because I am starting to count from 0. 0 will be 1 and 5 will be 6 because there's an additional 0 at the beginning. So to get the correct year, I need to minus 1 from this formula. Then I get 4. So this is the correct year when the positive cash flows or positive cumulative cash flows occur. Now I can't have this 22 hash inside the formula because the final formula, as I said, can only have this range over here for the after-tax cash flows, D12 to I12. So what I will do is I will first copy this. I'm going to replace this D22 hash with this scan formula. So I will copy that formula from here, Control C, and come here, and I will paste that over here. So this final formula also only has the range D12 to I12. So this is the match function final form. Now if I were to manually calculate the payback period, I can do it like this. I can come here, type equals, and I take the cash flow first year where the positive cash flow occurs from here, D25, and from that I can minus the cumulative cash flow in year 4 divided by the after-tax cash flow in year 4. So I get 3.2. So here we are basically, as I explained at the beginning, we are going to prorate or equally distribute the cash flow and calculate the fraction of the year when the break-even point happens. So that's what we did over here. Now the formula we have come up with is n minus x divided by y, like this, as I explained at the beginning. So for n here, I can take the n from the formula here in this cell, D25. Now I'm going to use a formula to calculate x, which is the cumulative cash flow for the first positive year. This one over here. So to do that, I can use a index function over here. So I'll type equals index. Then the array I want to check for is the cumulative cash flow array with the scan function over here. I can select that D15 and put hash for the spill range. Then the row number is the year where the positive cumulative cash flow occurs. That I can take from D25. I can close the bracket, press enter. So here I'm getting minus 25,000. So that reason is the cash flows I have adjusted by minusing 1 because we are starting the counter from 0. So we are ending up here in year 3 instead of year 4. So to remedy that, to D25, I can plus 1. So becomes 4 plus 1, 5. So now it is selecting the correct value for the fourth year, 100,000. Now again I have to replace this D15 hash and D25 with the other formulas that have the D12 to I12 reference only. So I'll first copy this formula, Control C, come here, Control V. Now D15 hash has to be replaced with this scan function over here. So I'll copy the scan function from here, Control C, come here, paste it over D15 hash, and still the formula gives the same result, so it's okay. And then I have to replace D25. So D25, I have this match function over here, so I will copy that and replace D25 with that function. So I get the same result, but finally the index function only has D12 to I12 range inside the formula. Then the next step is to calculate the after-tax cash flow in the first positive year. To do that, I again have to use the index function equals index, and the array here is the after-tax cash flows of the first of the years. So I will take it like this range, D12 to I12, put a comma, then the row number is 0, and the column number is D25, and I need to add a 1 to that so it goes into the next year, and I can press enter. So here and here I added the 1 to the D25 because I'm starting from year 0. To come to the correct year, 125,000 in year 4, I need to add 1 to D25. So again I have to do the same thing here, get rid of the D25 so that only the D12 to I12 is there. So D25 formula I need to replace. So I can Control C this, paste it over here, Control V, and the D25 formula I can copy from here. And I can paste it over D25. And I get the same answer. Now in the final two index functions, you'll see there's a -1 and +1 which cancels out. So here also it cancels out. So I can just delete those two just to make the formula simpler. And here also I can delete the -1 +1 because it's 0. But I get the same result. So that's fine. Now I can again calculate the final payback formula as D25, that's 4 years, minus C40 divided by C45. And this I can replace all of these references with the respective formulas. I'll just copy this here and Control V over here. And I need to replace D25. So D25 is this match function. I will copy it from here. Replace this. And I do the same thing for C40. And I do replace C45 also. So this is our final formula for the payback period. So I have done it in steps, so it's easy for you to follow the logic what I have done. So what I have done is basically build up the final formula using the steps that I would use if I were to do this manually. Now you'll see in this final formula, we have several places where we have the D12 to I12 range actually. So there's 1, 2, 3, 4, 5 times we are using the same range. So we can actually simplify this by using the let function. So the let function allows us to give a name to this range and use that name multiple times inside the formula. So this helps us in two ways. The let function makes the formula easy to read because we are only using a field name in these ranges all over the place. And also we will make it easy for Excel to calculate because Excel will be only calculating this range once. It will not be calculating all the time inside the formula every time it repeats when we use the let function. So let me first show you how the let function works. So here I'll write a simple formula for the let function equals let. And as you can see, you can give a name for a variable and then we can give a value for that variable. And we can give multiple variable names and values. And finally, we can give a calculation at the end. So let's give a simple name x. And for the value, I will give it as 10. And then I will give a calculation x plus 1. So that is the calculation x plus 1. And I can close the bracket and press enter. And I get 11 because 10 plus 1 is 11. So we can have multiple variables as well. So I can say equals let and we'll give the first variable x and make it 10 and we give another variable y and we'll give it the value 50 and then we can write the final formula x plus y and close bracket and I get 60. So here I have used numbers 10 and 50 for the values, but you can use basically cell references, you can use text, you can use numbers, other data types like Boolean and so on. So all of those values you can use as the name value. So let me give a cell reference instead of the 10. So I'll give this cell reference C47 and for Y I will give this cell reference and it gives the result. 4 plus 3.2 is 7.2. So in this, the final calculation here is a simple calculation x plus y. But if you have multiple occurrences of the x and y occurring here, this will be useful because you only have to give the value of x and y once and that calculation will be done. And everywhere there's x, y, those values will be substituted. So let me delete this. So here what we are going to do is basically everywhere we have D12 to I12, we are going to replace that with a variable value. So our formula becomes much more simpler and it's easier to read and it's easy for Excel to calculate. So let me first copy the formula from here. Control A, Control C to copy. I'll come here, Control V to paste. So I'll paste it over here as well. So in this formula over here, I'm going to start it with a let function. So I will type let and I have to give a name for the variable. So I will call it values. and put a comma, and values is going to be this range over here, D12 to I12. I put a comma again, and let me bring this down. And now since I opened a bracket over here, I need to close a bracket. I close that and press enter. So this formula now has the let in front, and we have defined values as D12 to I12. So everywhere in the formula that I have D12 to I12, I can replace that with the values variable name. So let me again, so Control A, copy that, Control C, and I will come here, paste it, Control V. Now I'm going to copy values from here, Control C, and everywhere, not here on the first one, but everywhere else where I have D12 to I12 cell reference, I'm going to paste that values. So 1, 2, 3, 4, 5, and that's all. So 5 times I have replaced D12 to I12 cell reference with the values variable name, and I still get the same answer. So I use let function to simplify the formula. Now what we are going to do is we are going to create a custom function for our payback period, and we'll be using this formula. So to make a custom function in Excel, we need a function in Excel called lambda. So the lambda function allows us to create our custom functions and name them. And also we don't need VBA to create functions if we are using the lambda function. So let me first show you how lambda works. I can type here equals lambda, and then I can give the parameters, and I can give, let's say, two variables, x and y, and then I'll give the calculation as x plus y. So I'm defining two variables x and y, and the calculation is x plus y. So if I enter here, I get a calc error. That is because I have not given any values for the x and y. So I can test the function like this. I can open a bracket at the end, and I can give two values for the x and y like this. So 10, comma, that is x, and y is going to be 50, and I can close the bracket and press enter, and I get 60. So that's basically how the lambda function works. So here we are going to use lambda function to convert this formula we have created over here into a custom function to calculate payback period. So first let me select this formula here, Control A to select everything, Control C to copy, and I will come here and Control V. And let me copy this formula so you can see. So this is the same formula. So I will again copy this and paste it over here. Now I will type lambda in front. And since I have used the let function to convert all of these cell references D12 to I12 into values inside the formula, I don't need the let function anymore. So I can delete the let function like this. And I don't need this cell reference as well, D12 to I12. So I will delete here up to match. So it will become values and then lambda values. That is the variable name, and then the rest of it is the formula we have created. So I can now press enter. And of course I get the calc error because I have not given values. If I want, I can check it like this. I can open bracket at the end, and for values, I'll give this range like this, close the bracket and press enter. Then I get 3.2 again because I have given the cell reference for the values. The formula is still correct. So I will remove this last part, and this is the lambda formula I have created. Now I can convert this into a named custom formula. First I will select this, Control C, and I will go to formulas, go to the define names, go to define name, and here I can give a name for the formula I'm going to create, the function. I'll call it PBP for payback period. The scope workbook means it will work on the whole of the workbook. If I want, I can restrict it to a sheet, but normally we have it as workbook. So it will work on all the sheets in this workbook. And by the way, when you create a custom formula like this, it will only work on this particular workbook. If you want to use it on another workbook, you will need to copy the formula and create that in the new workbook. Or you can copy one of the sheets from this workbook into the new workbook, and then the formula you have created will get transferred into the other workbook. So comments, I will leave it blank. So here I will delete this and paste the formula I created and click OK. Now if I come to the name manager, you see payback period, the function has been created. So let's test it out. Let's come here, and here I will type equals PBP and it comes up, tab. So I need to give the values. These are the arguments for the function I created, values. So I'll give this range and close the bracket and press enter. So I get 3.2. So this is the new payback period function we have created for ourselves. Now we have to create another function for the discounted payback period. We'll call it DPBP. So to create that, I'm on the other sheet. So I have the weighted average cost of capital. I'm going to have it as 11%. So that's the discount rate I'm going to apply for the cash flows. So this is the same data. So I have the year sequence already calculated with the sequence function from 1 to 5. And now I need to calculate a discount factor. So calculating discount factor, I can take it as 1 divided by 1 plus r to the power n. So I will take it as 1 divided by 1 plus, the discount rate is here, C8. So I'll use F4 to convert this into a fixed cell reference. And I can close the bracket. And I had take it to the power n. So n is 0 in this first situation. And I have 1. So I'll copy this formula across. So I'm getting the discount factors up to year 5. So this is year 5 discounted factor. Again, these formulas D15, I can use the sequence function to replace D15 over here. So let me copy this formula, paste it over here. And for the D15, I'm going to replace it with the sequence function from here. Then to calculate the discounted after-tax cash flows, normally I will take the cash flow like this, D12 into the original discount factor, the discount factor from here. And I can copy it across like this. Then to do this with dynamic functions, I can type like this equals. I will take this whole range cash flows here and multiply by the discount factor range here, the spill range. So what I'm doing is I'm taking D12 to I12, this cash flow range, and multiplying by the array for the discount factors, all of these. So they will get multiplied by the corresponding values, and I will get the spill range for that. So I get the same values. So original calculation is this. If I use the spill range, and I'm getting the same answer. So now I can replace the D18 hash with the formula that I have here with the sequence function. So let me copy this, paste it over here, and I'll copy the formula over here and replace the D18 hash with that formula. So I got the final array formula done for the discounted cash flows. So to get the cumulative discount cash flows, I'll use the scan function again, equals scan. Initial value will be 0. And I'll use the value from here, D22 hash, the spill range. And the function will be sum. I'm going to use at the end and press enter. So I get the cumulative cash flows, discounted cumulative cash flows from here. So I can replace the D22 hash with this formula over here. So I'll copy that, Control C, come here, replace that. I got the cumulative cash flows. Again, I have to check when positive cash flows are happening. So I'll use a logical formula like we used on the first formula, like we used on the first function, equals. I'll take the cash flows from here, spill range, and check whether it's greater than 0. And I get the false, false, false until true happens when the fourth year where I get a positive cash flow, discounted cash flow in the fourth year. So I get a true there. So again replace this D22 hash with the formula over here. So I'll copy this, Control C, and I will paste it over here, Control V. So again got the spill range. Now so far if you notice in all the formulas I have created finally, I'm allowing only the range of the after-tax cash flows D12 to I12 to be inside, and also I'm allowing this C8 where the discount rate is there to be inside the formula, because at the end of the day when we create our custom function for the discounted payback period, we will have to give two inputs. One will be the after-tax cash flows and other one will be the discount rate. So I'm making sure that only those two cell references are inside the final formula. Now I'm going to calculate the first year with the positive cumulative cash flow, the year number. So for that I will use a match function, equals match, and I'll search for true, comma, and the lookup array is D26 hash, and I'm going to look for an exact match. And that's my function. So I will again replace the D26 hash with this formula over here. So let me copy that and come here and paste it over here. That is my year of first positive cash flow calculation. So here it comes as year 5 instead of 4 because we start counting from year 0. So again at the end we need to minus 1. So we get year 4 is the year when we get the first positive cash flow, that is discounted cash flow. So to calculate the payback period, the only difference what we have done here is we are going by the discounted after tax cash flows and the discounted after tax cumulative cash flows. So we will use the same formula we used before. So we will type equals, take the first year with the positive cash flow, that is year 4, and from that I will minus X, which is the cumulative discount cash flow in the first positive year, divided by Y, which is the discounted after tax cash flow in the first positive year. So here X will be this cell over here, H24, divided by this cell over here, H22. And I get the discounted payback period is 3.86 years. So earlier we got 3.2 years. So the payback period increases because the discounted cash flows are going to have less value as the years progress. So always the discounted payback period will be higher than the normal payback period. So let's just put the first year when the positive cash flow occurs is D29. So that is year is 4. So let's find the cumulative discounted cash flow in the first positive year, that is the X. So I will use a index function here, index, and the array will be D24 hash, the cumulative cash flow range, and the row number is 0, and the column number is the year when we have the first positive cash flow. So I'll take it from here, D29, and close the bracket, press enter. So again, I'm getting the negative value in year 3 because the years start counting from 0. So to remedy that, again, I will have to add 1. So here I will add 1 and I get 11,377. That is the year 4 cumulative discounted cash flow. So I have to calculate Y, discounted after tax cash flow in the first positive year. Again, I'll use an index function and the array will be D22 hash and row number is 0 and the column number is going to be D29. I can close bracket, press enter. Then I get 73. So that is year 3 value. I need to get the year 4. So this happens because we are taking the counter from year 0. So like before, I need to add 1 to go to the correct year. So D29 plus 1. So now I'm going to get rid of the D24 hash, D29, D22 hash, and D29 from these formulas. So let me just copy this. Paste it over here. So D24 hash, I will copy from here, Control C, and paste it over here, Control V, and D29, take it from here, copy that, and paste it over here. So this is the formula. So at the end there's a -1 and +1. Again, I will just delete that because it becomes 0. So get the same value. So this formula, so I will copy, paste it over here, replace D22 hash. And replace D29. Again, I get a -1 +1 at the end. So I just delete that. And I still get the same value, so it's correct. Now I can calculate the discounted payback period equals first year when the cumulative cash flow is positive, 4 from here, minus x, that is this x divided by y, 3.86. So this is the same 3.86. So let me copy this. I'm going to replace the cell references with the relevant formulas. So D38 comes from D29. So D29 is this. Control C, Control V, and C45. Replace that. And then C50. Replace that. And we have the final formula. So this is our final discounted payback period formula. So let me copy this. Control C, Control V, paste it here as well. So I'm going to now again use the let function to create two variables called values for this range and another variable called rate for the discount factor. So I will type it in front, equals let values and I have to give this range D12 to I12, comma, and then I'm going to call this the discount rate, comma, and I give this cell reference C8 and comma. So now I opened a new open bracket for the let function. I need to put a final closing bracket and press enter. So this is the let function. So now I need to replace the values. So I'm going to take values from here, Control C, and I'm going to change all of these D12 to I12 into values field. I'm going to just paste them over. So I have now replaced the values field. Now I'm going to replace the rate. Copy rate, and everywhere there is a C8. I will replace that with the rate. And that's all. So all of the cell references for the values and the rate have been changed into these variable names. Now I can use the lambda function to create our custom payback period function. So let me copy this, Control A, Control C, and let's paste it over here. And now I'm going to type a lambda function in the front. Lambda. Now I don't need the let function anymore. So I will delete the let function, leaving the variable name values and the rate. So only values and rate variable names are there from the previous let function. So I get the hash calc error because I have not given the values for the two variables. So I can open bracket like this and just check whether it's okay. So I'll give for the values this range, put a comma, and for the rate, I will give the cell reference over here. Close bracket, press enter, and I still get the same value. So it's okay. So let's copy this here down over here, and I'll delete the cell references. So this is our final formula. So I can create the custom function using this formula. So let me Control A here, Control C to copy. I'll go to formulas, define name, and I will call it DPBP, discounted payback period. Workbook scope, come inside leave blank, and I will delete this and paste the new formula I created and click OK. And the name manager now has the discounted payback period and the payback period. Custom formulas are there. So let's check it out. So I will use it over here, equals DP BP, and I have to give the values, the cash flows, and the rate, and close bracket, press enter. So 3.86. So that's the calculation I got from the manual calculation as well. So it's correct. So now I have the discounted payback period function also created. So we had to only go through all of this trouble the first time we create the function. Thereafter, we can just copy it and use it. Also, rather than create two functions, one for regular payback period and other one for discounted payback period, you probably can use just the discounted payback period for both. And when you don't want the discounted payback period, you can use 0 for the rate. So that will give you the same result as the undiscounted payback period. So if I delete over here and put 0, I get 3.2. So that is the same I got for the undiscounted payback period. So this is how we can create our own payback period function, and just have to go to a bit of trouble to create the formula for the first time, but thereafter you can just copy and use it easily. So hope this was useful, and thanks for watching.
Are you looking for a better and smart way to learn Excel? then you need to check out our innovative new Excel learning app. Our app delivers Excel training courses directly inside your Excel application itself for a truly immersive and novel learning experience. With our app, there is no need to watch tutorials outside the Excel application, download Excel files, and then come into Excel to practice. All lecture videos, practice files, and other resources are accessible from inside your Excel application. The app will provide you with a unique and immersive learning experience with minimum distractions and hassle. You can watch streaming video tutorials directly inside the Excel application. The video screen can be resized as required by dragging the app pane or by using picture-in-picture mode to watch while you practice. Excel practice files can be loaded directly onto your Excel application using the Load button. With the app, there is no need to download files separately and open in Excel manually, as with other training solutions. Once you have finished practicing on a file, you can clear the loaded file with the Clear button and load another file to practice as required. A Download button is available if you want to download files for later use. Additional learning resources such as quizzes, practice tests, assignments, and coding exercises are all accessible from inside Excel through the app as well. Our app will provide you with a unique and immersive learning experience with minimum distractions and hassle. The app is compatible with all of these Excel versions. Our app is provided free of charge to all who purchase Excel courses on our course marketplace. You can use the app or learn on our site as well. To get the app, you need to first sign up and purchase an Excel course from our site. Installing the app onto your Excel application is very easy and straightforward. First, you need to open up your Excel application and go to Add-ins on the Home tab of the ribbon. Then just click on Add-ins and search for Ethnos in the search bar. Then select Ethnos for Excel and click on Add. Once you add our app to your Excel application, it will appear on your ribbon. You can log into the app using the same credentials you used on our site for your course purchase. Once logged in, you can access all your courses from inside the Excel application. So go ahead and buy a course and try it on our app. We can guarantee it will be the best Excel learning experience you can have. Now, if you like this video, why not subscribe to support us and get notifications so you don't miss any of our future videos. Thanks for watching, and I'll catch you next time.